Hey, what's up, dudes? Okay, so we're gonna do a late hour today. I had dinner, or lunch rather, with my mom and spent some time with her. It was nice. So, late start today, but we're gonna try to get something done. At least a little bit. I really didn't want to go without doing anything today. So let's figure out where we stopped yesterday. Yesterday we stopped at line, well not yesterday, day before yesterday rather. We stopped at line 333 in client refactor. Okay. And we were working on solution for save file formats and data retrieval save logic, which I think we finally finalized. We finally finalized our decision for the save file format and retrieval / save logic. We really finally got the ball rolling with actually like adding in the code. We were moved basically beyond the level of brainstorming and have finally put boots on the ground and got code written. Okay, so let's see what we got going on here. We'll just start from the top here. Let's see, refresh. So we have if name is equal to main, then we have our try while true. This is the outer loop for the menu screen, so that if we have a soft disconnect, which would result in a connection error but wouldn't kill the script, then we would still be inside of the script. Therefore, this while true would keep it all going, you know, as opposed to if we just hit the try except within the game or within the next main while loop, that would be broken out of. But this will ensure that the script will keep running and we'll bring them back to the menu screen if they disconnect from a game, right? Okay, so let's see if it's working here. Make sure everything's all good. Main while loop, but that would be broken. Yeah, it looks. Everything's all good. Main while loop. But yep, it works. Cool. Okay, so back to this. Yeah, so we have our main while loop, and then feeder code for checking if save file is populated. If it is, that means it's an either soft or a hard reconnect. We have to attempt to load this to be able to reference the offset byte location. So when we say offset, we're referring to the byte location of game ID is checked next. So then we have save file equals CS save file pickle, and that should be the correct string to reference it because it is indeed in this same folder, the main folder. So from this client file's perspective, it's not like any steps away as far as folders go. It's not up a directory or whatever. It's in this same directory. So this save file string should work when passed to the OS path get size method. At least that's what we hope anyway. And we could test this by creating we'll say a new file here, and we'll just call it get size test and in it we will have, well, we actually won't have anything in it. And then let's go over here to test reminders. We'll go to next for the next segment. Go down. And then we're gonna do OS, and then we're gonna say x equals, oops, well, we want to do os.getSize of, and we're gonna pass in, we'll call f for file, and we'll say that it is get size test pi. So now we'll get size of f, and let's see if this works. So it's not written correctly. It's os.path.getSize. It's not getSize of. Since we're not finding the file, get size underscore test.py. So apparently this is not actually gonna work. Okay. So that is not correctly written. If we have a folder testing with with file f get size test pi. If we have a folder testing called testing with file f titled get size test pi in it, and another file called test reminders.py, and we want to use os.path to get the size of the file f. What would be corrected in the above code? Detailed function ensures the correct file size with the unit specify the correct path. So the folder structure is testing, get size, test reminders. We do this folder is testing name equals get size underscore test pi. Construct the full path to the file name. File path equals os path join folder file name. Ah, okay, so that's what is missing. It's got to do the dot join, so it joins the path of the folder with the file name. God. Couldn't you just to ensure the fast constructor really? Replace f with the variable holding the full file path. Dynamically build paths using folder and file name to ensure flexibility and avoid hard coding paths. For example, see. What is wrong with the code? Okay, so that, okay, I see. There isn't a way to get the exact path from the relative location of the file you are working from, aka test reminders, instead of if you knew the name of the folder, you could access it dynamically. So that would be the directory of the current script, os path dir name file equals os path join directory. So the os path directory or file it's a special variable in Python that gives the absolute path of the currently running script. Test reminders in this case. Special variable is absolute path of the currently running script. Their name retrieves the directory containing the current script. Dynamic path construction combines the current directory with the file name, size, test, read the full path. No need to hard code the folder name. Looks even if the folder name changes, as long as the files are in the same directory, relative position remain consistent. Yeah, I would rather use that way. So we'd use os path dir name and join. We'll join the current directory. Okay. So if we do, first of all, let's do os dot path dot, what is it? Is it dunder file? Path dot dir name. And then dir file. And then if we do print, so it gives us programming projects to Canasta testing. Okay, so it does give us the directory, the folder. It doesn't give us the actual file. Okay. So then that would be current dir name file. And then use equals os size. Then we'd have to do os.path.join and current directory with the, so we put F here. System cannot find the file specified get size test. I'm just like, I'm pretty sure that's spelled correctly, right? So if we rename this, is it because it's empty? I think that would be the issue. if we make sure it's it says it can't find it. So if we print the current directory, let's print the current directory, see what we get. So we get, and then, so we get testing, and then if we join, and it's inside of testing, so I don't understand what the problem is. I'm confused. If it's in testing, well then, why does that not work? What's wrong with that? It's OS path get size. Oh, I'm an idiot. I'm dumb. I'm dumb, guys. So, we'll call this J for joined. I'm an idiot. There we go. Okay. And print X. Yeah, you get 4. Okay. So, we got that figured out now. I'm a dummy. Let's copy this code and we'll fix it. Let's comment this out. And we don't need that. We don't need that. So this is all we need, really. And so we're going to fix this to be current dir. There we go. So we'll have that there. Then we'll do get size test. Well, we're not doing a test file. This set. So we'll get the current directory. We have the save file, and then we'll do call this the save file directory or save file location. Okay, I know this is a really dumb question, but a directory in programming is a folder, right? Not a file? Or is a directory just a location altogether? The directory refers to a folder. Directory can, yeah, so I thought that was right. So a directory is a folder. It's not a file. You don't call files a directory. You call a folder a directory. Container for organizing files and subdirectories, for example, directory name testing. Gotcha. Okay, that's like one. So I was gonna call it save file directory. That's not the directory. That's actually the location. So OS path join current directory with the save file. Now, there we go. So this should actually, if OS path get size of the save file location, so we have save file equals cs save file pickle. Then we get the current directory using OS path dir name. So this gets the current closest, or we'll just call it the current files parent directory to access the save file, which is in the same directory. Alright, and then gets the specific save files location on the storage device, And then if OS path get size of the file location is equal to 0, yeah, that should work, I think, because this will account for the save file location should be proper, I think. So if OS path get size save file location is equal to 0, is reconnect equals false. Alright, so we're good here. Let's go ahead and go back to test reminders real quick. And I'll put the date. Say reminder that this is how you can dynamically access a file's location if it is in the same directory as the current working file. So this is really just, you know, a specific case scenario. We'll call it working file access working files working file directories other files. Yeah. And this is actually a dynamic because it doesn't really rely on like you having any specific knowledge of the file names. You know, this would work like universally. It doesn't really require well, you do have to have the file name of like the file that you're looking for, obviously, but you don't have to have the directory name or anything like that, or the like even the current file that you're working from, which is kind of silly. But anyway, that's a way to do it. It's fine. It's not important further with that. Right, so that should work now. And then we have, so in this case, is reconnect is equal to false, because if the size of the save location is equal to 0, then well, actually, okay, this is a save file string, and then this would be the save file would actually be save file string here. So let's packet size, and then this is going to be just save file. This is actually more accurate. This is a string that represents the save file. This is the current directory, and then this is the save file itself, because it uses OS path to join the current directory with the save file string, which references the save file, right? So then if we just say OS path get size of the save file, that should work. Yeah. And in this case, we know reconnect is false because nothing has been saved to the save file. If something had been saved to the save file, that means we know it is a reconnect, because, well, that means well, does that actually mean that a game has been started? So, like, let's think this through a little further. If OS path get size, if the save file size is equal to 0, meaning that the file is empty, does that necessarily mean that it's a reconnect? I'm not sure. That it's not a reconnect. I don't necessarily think that does give you knowledge of that, because, well, what's the first thing that gets saved? This depends on some things, right? Right, so we have the save file offset dictionary, and then we have the game ID. So these are the first two objects that get saved, at least currently. And that's actually still in the works. So we have this written here. Realize we actually don't need the offset dict to get the game ID because we know the game ID would be the first or second object in the save file. Probably want to refactor this section according to that truth. Would also want to determine whether we want the game ID to be the first object saved to the save file, since we don't need the offset dict until the third or so object. Since we do know some of the constant order of objects we will encounter, therefore we know the save order. Therefore we don't need the offset values at this early section of the game. Okay, and that is true, and that's kind of what I was just has to do with what I was getting at there when I was questioning whether or not this actually would accurately like determine this boolean, which is the logic that determines whether or not we're reconnecting to the game or not, to a pre-existing game. So let me read that one more time. Don't need the offset dict to get the game ID because we know the game ID would be the first or second object in the save file. Right, so we don't actually need the offset dictionary to get the game ID because, well, if the game ID is always going to be the first object in the save file, which we're almost certain that it will be, then we don't actually need that dictionary to get it. This pseudocode that loads in the save file offset dict, which is the game ID, this actually doesn't happen. Like, it doesn't need to happen to get that data. If the game ID is always the first object, you see? So anyway, we'll leave this code though, but let's read the latter part of this. We have probably want to refactor this section according to that truth. Would also want to determine whether we want the game ID to be the first object saved to save file, since we don't need the offset dict until the third or so object, since we do know some of the constant order objects we'll encounter, or we know the save order of offset values in this early section. Okay, right. So I understand all that. We still need this code eventually, right? Like we have to. Well, hold up. Let's think about this for a second. If we don't no, because we don't have to have it loaded in first, right? Like we can load in the game ID first, which would be the actual first object here, which says so I think we're gonna tinker around with this. This is not gonna be the final form, I think, because also if the file is empty, okay, yeah, so if the file is empty, that definitely does mean reconnect is false, right? Because how could we restart a game wherein when we start a game we are given the ID? So if when we start the game we're given the ID and we don't have the ID, well then that means we haven't started a game, so it can't be a reconnect. So I think this actually is correctly coded, this little section here. I think that's right. Yeah, that makes sense. As granted, like well, granted that the first thing that we receive is the game ID. So if we were to have the save file offset dictionary be the first saved object, and that is saved prior to reception of the game ID, which is synonymous with the starting of a new game, then actually even if the size of the file wasn't 0, that still doesn't necessarily mean that well, basically all that means is the size of the file is irrelevant as far as determining whether or not it's a reconnect. In that case, it would still not be possible that it could be a reconnect, but considering the fact that the game ID could also be contained in the size of the file, we can't use that as a determining factor if we were going to save the save file offset dictionary first. So this really relies on whether or not game ID is saved first. If it is not, then this won't actually matter in terms of determining whether we are dealing with a possible reconnect or not. It just doesn't matter. So we have if, else, then we have this with open save file, and yeah, we still have, okay, so this save file is going to properly reference the joined directory. Like so this location should be accurate now. But as a matter of fact, this would not load in the save file offset dictionary, would it? If the game ID is going to be first. So that's our next question. Our next question is, what do we want to be our first saved object? And I would say, if we want to use the size of the file to determine whether or not it's a reconnect, well, want the game ID to be saved first. But it doesn't really matter whether the game ID is saved first or second, because even if it's second, we could just do a second, or we could, well, yeah, we would just do a double load, because we know it would be the second object instead of the first. Granted that the save file offset dict would be the first object, blah 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 blah. So we could just like access it in that way, and then check the value of the actual we could check the value of the actual object itself, as opposed to checking to see if the file is empty. So like, honestly, it is a bit arbitrary as far as clarity in definitive purpose as far as the wording goes, using the size to determine whether or not it's a reconnect. So that's strange behavior, but I mean, there's not really anything wrong with it per se. So we have with open save file RB, loaded in save file offset dictionary, load first object, and we said it was always be the save file offset dictionary, but that, like we said, we actually don't need the offset dictionary for the first few objects. So we definitely do need the dictionary, almost certainly, like for sure. But we don't need it. Well, I would say if we wanted to instantly travel to the location of the object that we're looking for in the save file, as opposed to doing multiple loads, you know what I'm saying? Then yeah, so I I mean at this earliest stage, you could say it wouldn't really matter. We could just do the game ID first, and then the save file offset dictionary second, so that when we checked the size of the file, it would be a quick way to determine whether or not reconnect is possible. Um, but the chance that the size of, well, I guess the chance of that is arbitrary as well. Like it could be like 50-50, you could say, or whatever. Um, I don't really want to bring it down to like probability or whatever, but go and save file RB, loaded and save file, set dictionary, pick a load save file. So yeah, I think honestly, we wouldn't really use this to determine whether or not it's a reconnect, because if we're gonna save the save file offset dictionary first, which I honestly I think we should. I think we should like have that be the first object, because that is the object by which we know where to access all the subsequent objects in the save file. I think it just like makes sense for that to be the first one. Um, just to change that to get some little quick way to check whether or not a reconnect is possible is sort of silly. And also, like I said, the naming is like the wording is not related to like the game ID, which is what we're actually looking for. So it's kind of like implicit, and we like to be explicit, right? We like to be clear, not to be hiding behind some other namespace that is completely unrelated. You know, it's related in reality, but conceptually, it doesn't tie in at all. So we're actually going to change this. This is not going to be. We're going to say if this is going to be game ID is equal to, well, I guess actually what we could do well, we still would need to check this, right? Like this would have a different purpose. We're checking the save file to see if we have saved the offset dictionary, right? And because this is a PKL file, we can't pre-populate it using like plain English or Python or whatever, like we would be able to do with a JSON file, because you know I don't know how to write in hex code or byte stream or whatever. Anyway, so what this line would do in the case that I think what we're going to go with is it's going to check to see if the length of the file is greater than 0. If it is, that means we have the save file offset dictionary, and that's just going to be a basic check to see if we have that. So this is not going to be associated with is reconnect. So we're going to get rid of this. This is going to start off, and we'll just put this as none as a placeholder. And I'll put, here we go, below line. We'll say 115, put the date here, 25, baby. And we'll say type bool, and boo. That's funny. Type bool, and then purpose to determine whether it is possible that, not possible, like that, whether it is, not, yeah, because it's possible that they want to reconnect to that game, but it's certain that they did disconnect from a game. They determine whether the new screen should allow for reconnection to a DC'd game. True indicates that it is a reconnect session. Yeah, and we'll just leave this as none, and we'll just put default value to none for placeholding purpose. Okay. So then we check to see if status file is equal to 0. This means the save file is empty, and that's really all we put here. And this means well, that means that we need to first save the offset dictionary to the save file, right? Yeah. So if there's nothing in the save file, then we need to client save file offset dictionary. So what does this default to? This defaults to just a empty dictionary. Dict purposes use which has key equal to data structure name and value is equal to associated save files offset location. Okay. So in this case, this would actually, we need to run this, right? Need to, well, no, that's not true. We don't have one at all. So what we could do, well, so I'm trying to think of what logic would follow here, because we don't actually want to go ahead and save the save, like we don't want to save an empty save file offset dictionary. We don't want to save it until it actually has its first value, and that first value wouldn't exist until we have the game ID, right? So what exactly do we do in this scenario when the save file is empty? Well, then that means we need to get the game ID, and then we need to add the game, well, oh, you know what I just realized? Oh man. I'm not sure we can use an offset dictionary. Like, because doesn't it mean that whenever, like, if we were to use an offset dictionary that's consists of various objects inside of the save file, and they were arbitrary lengths, like the offset is actually a certain like value that is determined by the length of the object that is saved. So let's say the first object's offset starts at 0, of course, because at the beginning of the file. But let's say the length of that object in bytes is 50. So then that means the next object's offset value would be 51. You know, and so on and so forth. But now let's say we go ahead and modify the first value, right? Let's say we modify the first value, and now we have a byte length of 30. So does that mean that the second object will move to 31? You know what I mean? Like, obviously, if you rewrite the first object, I don't know how that works exactly. I am an idiot. I should have thought about that a little earlier. I mean, this is new to me, but still. So I need to understand this better. Let's say, okay, suppose we are using offset byte locations in a PKL save file to refer to each pickled object's location in the save file. If the first object started at at offset 0 and was 50 bytes long, therefore the second object started at, or let's say, does that mean the second object pickled would start at offset 51? Also, if we were to subsequently save the second object and then seek the file to offset 0 and overwrite the first object with a new smaller, let's just say 30 byte object, would that, so we're able to if we were to subsequently save the second object and then seek the file to offset 0 and overwrite the first object with a new smaller 30 byte object, would that move the second object's offset location to start at 31 instead of the previous 51? Also, what if the overwriting first object was bigger instead of smaller, being, you know, 60 bytes instead of the initial 50? Would that imply the second object has been partially overwritten since it started at 51, or would it move the second object ahead to have a new offset value 61, since 10 is the difference between 60 and 50? Okay, that's a lot, but I mean, ChatGPT is smart. ChatGPT will understand. So, um, let's see. If the first object starts at offset 0 and is 50 bytes long, the second object would typically start at offset 50, not offset 51. This is because the offset refers to the exact position in the file, and offsets are 0 based. Okay, so if it's 50 bytes long, okay, right, because the offset starts are 0 based. So 0 plus it's like 0 indexing, right? So 50 would come after 50, not 51, because you're starting at 0. I get it. Gotcha. So it would occupy 0 through 49, but would still be 50 bytes long, and then therefore offset 50 would refer to the beginning of the second object. Gotcha. Okay, so it would be written immediately after the first object, so it starts as the next byte. Okay, that makes sense. So overwriting the first object, if you seek back to offset 0 and overwrite the first object with a new smaller object, the second object's offset would not automatically change unless you explicitly rewrite the second object at a new location in the file. If you do not explicitly manage offsets or rewrite the second object would still be considered to start at its original offset 50. However, there would now be a 20 byte gap between the first and second objects. Okay, fair enough. If the overwritten first object is larger, 60 bytes, in this case, if you write 60 bytes for the new first object and do nothing else, if the overwritten first object is larger, in this case, if you write 60 bytes for the first new object and do nothing else, the second object would start at offset 50 as before and would be partially overwritten by the extra 10 bytes of the first new object. The file system or Python will not move the second object. This means you would overwrite the first 10 bytes of the second object, corrupting it. Okay. Offsets are fixed unless managed explicitly if you want to adjust it. Okay, overwriting a larger project causes data loss. If you overwrite an object with a larger one and don't account for the new size, it will overwrite subsequent data. Explicit file layout management is required. When dealing with offsets and files, you must carefully track and manage the position of each object, especially when performing modifications. Okay, track object size and offsets. Track each object's offset and size. Okay. If an object's file changes and you want to keep the file contiguous, no gaps, you may need to rewrite the entire file. Ooh, okay. Ah, I see. So this is actually kind of a big problem with this whole offset, like, thing. This is actually a big problem. So, initially we were going to use JSON, but then we decided to use Pickle because it was much faster. So we did a test, and let's see, we determined that Pickle was 4 times faster um, than JSON was, based on the test that we did. And let's see. Let's run this test one more time, and I want to see real quick. Test. Okay. There we go. So we have, yeah, Pickle is very fast because it's written in bytes. Okay, but JSON, so it's about 4 times faster, almost exactly 4 times. So that's actually accurate. Okay, so I think that, well, damn, we might. I mean, that's actually kind of a long time, right? Like 2.8 seconds. Well, that's because it was doing it 10,000 times. So, let's see. Doing this, let's see. We change the number. Where's number? So iterations. Let's change the iteration to just, well, one. That would tell us how fast it is to do it one time. So to do one JSON serialization and then a deserialization, it takes 0.0001 second for pickle, and it takes JSON 0.0003. So it's actually four. It's closer to 4. So it's 4 times. Still, pickle's still 4 times faster. Now, that does seem like nothing, right? But if we're, constantly saving data and stuff, yeah, that stuff can add up. I mean, that is going to be happening constantly. So I don't want to say the performance difference is nothing. Like, but what was the iteration before was 10,000. So 10,000 serialization and deserialization are only take 2.5 seconds, like 3 seconds for JSON, and that's like a lot, right? I would say an entire while loop of the game would probably be less than 100 objects. It would probably be closer to like 50. Let's just say we have 50, and granted, this is still doubled because we're doing serialization and deserialization, but in reality, we would actually only be needing to do serialization. You know what I mean? We're only going to be really saving. The only time we're going to deserialize or load be we would only do that one time in the case of a reconnect. So let's actually change this to reflect that fact. So now we have it's just crazy, bro. Okay, so you see I look like a monk, like something's wrong here. Well, normally I cut my hair, like I leave it a little on the sides, right? I didn't like how it was growing out and sticking up. It was growing out and sticking up fast. I used to let it grow long, and it would just kind of lay down. But then in the summer, if it got really hot, it would poof. And I didn't like how that looked. I just didn't like it. It would like poof up. I looked like a clown. I didn't like it. So I was like, I'm gonna start cutting this short. Well, I cut it short, but it only took like 3 days, and it was sticking up again. And it just kind of like, it was bothering me. It looked like just didn't look right, you know what I mean? Sticking up like spikes on the side right here. So I was like, I want to cut it really close, but we didn't have the guards. We didn't have the guards, so we just had to go all the way to the skin. My mom, I was like, fuck it, just go all the way to the skin, whatever. And as you can see, now bald on the sides of my head. I don't like how it looks. I feel really silly, but it is what it is, guys. Like, I can't. It's there, and anyway, it'll grow back so fast though. Within a couple days, it won't be bald anymore, and I won't look like fucking weirdo. At least not as much. God, it's just so weird looking to me. It's the contrast is extraordinary. Anyway, so we're gonna survive, right? And you gotta be able to laugh at yourself sometimes. don't want to look like a complete fucking idiot though, like I do. Like I feel like that's how I look. Anyway, well, back to this. So 10,000 iterations of only serialization. We still, well, okay. So Pickle's actually 5 times faster. It's even faster for serialization, which is major. Now, granted, let's just say we're going to be doing 50. Let's say 50 per while loop. It's actually a lot though, because we're doing a while loop basically like every frame, right? No, that's not true. Yeah, that's actually not true. Well, we actually would need to check, like, so we're gonna have to save the card location. So anytime the screen gets redrawn and stuff, like anytime a card moves or whatever, or any data point change happens, I'm just trying to think of a number here. Like what is the actual number of like data point changes per let's just say like per second maybe, or it's not quite as many as I would think like that it could be, right? Now when we're moving cards, then it's going to be really high. Like, well, we would just actually be overwriting the X, the Y. We'd actually just be overwriting one card's X/Y at a time, which is actually only 2 data points. So that's actually not a lot. Like, granted, they're gonna be updated and needed to be saved like every time that they're moved. So that means I would say that's like 50 times a second. Like, that's kind of a lot, actually. Let's just say, even, you know, on the higher end, let's say like 300. And I'm trying to be accurate here in my assessment, because this is actually, well, it's kind of important, because if we were to use JSON and it's 5 times slower and we're doing it a lot, then it actually could like eat into our performance time. You know what I mean? Like, is that true though? If we used multi-threading, but multi-threading isn't true concurrency with Python. But it still uses actual multiple threads, right? So you still do gain some performance by using another thread. Like if we had a save thread, which is actually the plan, what we're gonna do, we're gonna have a separate thread that is constantly saving any data that gets changed. I don't want to overthink this, right? But I also don't want to be an idiot, and yeah, I don't want to be dumb. and under assess, but I don't want to be like too focused on the micro that I am just being silly, you know what I mean? Straining at a gnat, or I guess you could call it. So if we did 300 iterations, that doesn't even take a tenth of a second. And I would like to think that that would be fine. I would like to think that would not interfere, because if we're gonna do 300 serializations, 300 saves per second, then this would actually be this would account for only like 4.4% of that time, right? Isn't that like kind of math? You see with the math I'm doing there? With if in 1 second of gameplay we did 300 data point changes, which equated to 300 serialization calls, that would, you know, that time it would take to do those 300 JSON calls be let's just say 5% of a second, because yeah, tenth of a second would be 10%. Yeah, so this is like basically nothing. As opposed to Pickle, though, Pickle is like so fast. It's not even 1% of a second. Now, the problem here with using Pickle, of course, is the fact that we have this offset issue. So the issue with the offset is the fact that whenever we try to use this system based on the like current proposition I have for it, it would have a severe issue wherein we would have inconsistent offset as objects were rewritten. You know what I mean? So like, or resaved, as objects were resaved at certain locations, because we were using the offsets basically like a list index to refer to that object so that we could seek to it immediately, like we would using a dictionary as if we chose the JSON option. We're doing that because Pickle's so much faster. But if, well, first of all, I don't actually know how possible it would be for us to like do this now, considering understanding of how offsets work and the fact that if you have an object here, it at 50 byte lengths, and the second object would be located starting at 51 onward, and then you subsequently overwrote the first object to the save file, but let's say the byte length was 60, you could no longer use the second object's offset that is currently saved to reference that object. That object actually would be partially overwritten as well. So you would not only lose the offset reference, but of the second object, you would also have to resave the second object altogether, which means that, let's say if you have 30 objects and you change the first object to a longer amount, that means all the subsequent, the second, third, all the way through to the 30th, every single object in that file, you're no longer going to have an accurate offset location for that object, which means you would have to hit those again. So that would require getting the offsets like of them, which would require, well, I'm pretty sure that would require loading each object and getting the offset like manually. You would have to literally go through and reload all 30 of those objects, which in that instance would completely nullify any performance gains that Pickle would give you, because with JSON you could just use a dictionary to, like, you don't need the offsets. The dictionary keys are the offsets. So maybe there's a way, like, for instance, let's just say we would give each let's say we know that the byte length of each object is going to be between 10 and 80. Well, let's say we gave each object 100 bytes to work with, so that we would basically never overwrite the next object in line. See what I'm saying? So that would, ensure that we would never encounter this problem with the overwriting of objects in the pickle file, and we could therefore maintain the usage of those indices, aka the offset values, to reference those objects. That is possible, but if the varying of object sizes is too great, for instance, let's say a small object like a boolean or just a single integer is only like 8 or something, like I think it is, and then let's say one of these larger lists or whatever maybe complex object that we might save is like 1,000 bytes. Well, in that case, we're not going to allocate 1,000 bytes to each object, because, well, I guess we could do that, but I don't really know enough about files and like traversing performance-wise, or how that would affect performance if you could do that without messing things up, if that makes sense, to where like an integer is only going to take up bytes, but you give it 1,000 bytes of space, and then basically you would have to use the largest object. And see, so basically I am envisioning a system that might be really complicated using Pickle that would be 5 times faster. But if it's going to be that complicated, and if JSON is fine, it's not really going to mess up the performance of the game, then shouldn't we just be able to go with JSON? Because JSON is so simple. It solves all those logical problems off the bat. It's also human readable. I can pre-create some of the JSON. I can create the keys, you know what I mean? Which doesn't necessarily have to happen. Anyway, it's easy. It's super easy. It's basically like a streamline of a complicated process at the expense of a little less performance. So the question is, would the performance benefit be worth the extra work? I'm kind of leaning towards probably not. I think it is cool to do certain things that are just fast and performant, but I am more of a productionist. I just want to like get it done. I'm not so much focused on just performance. I'm more focused on if it's like 90% as fast, or if Pickle makes it 1% slower and Jason makes it like 5% slower, if that doesn't really affect anything for the user, I would just use Jason. Let me just ask, maybe there's a simple solution. So, for Pickle that is. So if I use PKL instead of Jason and use offsets to act as indices of object locations to seek to each object's location in the file to load that specific object, wherein the opposite system would use Jason. Jason's dictionary style to accomplish the same object referencing, except using the key value system. The key values. Would there be a way to ensure we weren't overwriting subsequent objects in the PKL file if we weren't overwriting subsequent objects relative to the current object we are overwriting. Yeah, so would there be a way to ensure we weren't overwriting subsequent objects, and we'll say subsequent relative to the current relative to the current object we are overwriting, i.e. object 1 versus the subsequent object 2 in the previous example. So would there be a way to ensure we weren't overwriting subsequent objects subsequent relative to the current object we were overwriting, i.e. object 1 versus 1 in the previous example? Yeah, there we go. I was like, where do I put the second? Parentheses. Okay, anyway, in the PK file, how do we finish this up? So if we use PK instead of Jason, use offsets to act as indices of objects' locations to seek to each object's location in the file to load that specific object, wherein the opposite system would use Jason's dictionary style to accomplish the same object referencing, except using key values. Would there be a way to ensure we weren't overwriting subsequent objects subsequent relatives to the current object we are overwriting, i.e. object 1 versus the subsequent object 2 in the previous example, in the PKO file? If we would there be a way to ensure we weren't overwriting subsequent objects in the PKO file, perhaps by using a buffer space, a buffer of empty space after each object to ensure non-overwriting, or some other system that would accomplish the same goal using PKO. Okay, that's a long one, but yeah, I know ChatGPT is fast as fuck, boy. Yes, it is possible to design a robust system for managing offsets in PKO file to ensure that overwriting one object does not accidentally overwrite subsequent objects. A buffered approach or dynamic offset management system could work well for this purpose. Below are a few strategies. Using a fixed size buffer after each object, you can allocate a buffer of empty space after each object in the file. This ensures that even if the object grows slightly in size, it won't overwrite subsequent objects. For example, each object is written to the file along with a fixed buffer. 20 bytes of padding. Overwriting an object, as long as its new size is less than or equal to its original size, buffer subsequent objects remain unaffected. Right, but okay, I understand that. That's fine. Press overwriting. Simply limit predictable flow structure. Waste to space if buffer is too large. If an object grows larger than the buffer, it still requires manual reorganization. Or using a metadata index for dynamic offsets. So instead of fixed buffers, you can maintain a metadata index that maps each object's location and size. A metadata index that maps each object's location and size. This index can be stored in the file itself. You have to start or end of the file or in a separate file. Load the metadata to determine where each object is stored. When overwriting an object, check if new size exceeds the old size. If yes, adjust the offsets of all subsequent objects. Yeah, but then you have to rewrite the entire file. So like, that would mean you would have to yeah, that means you would have to rewrite the entire file, right? Check if new size exceeds the old size if you have yeah, but yeah, then you're gonna have to new size greater than metadata key size, reorganize file to create space. So you're gonna have to rewrite all the subsequent objects. Yeah, so you have to open and then read. Then you have to seek to the offset and then write. Adjust offset, seek offset plus new size, right, for subsequent objects. But you would have to use like a for loop, like you would have to do this over and over again, right? Wouldn't you? Where's the for loop at? You need a for loop, right? Yeah, so for KV, if key found offset size diff. What is this? Update subsequent offsets. Okay, and then no wasted space, and there is no buffer. Highly flexible and efficient for dynamic size objects. More complex to implement, may require rewriting large parts of the file if an object size increases significantly. Well, yeah, I mean, if you have one object that gets larger, like that's the same system. It doesn't use a buffer. I'm sort of like confused. What exactly? Yeah, but if you're rewriting, I guess it doesn't understand. Like, I didn't tell it that I'm gonna be frequently resaving. Check see if the new size. If yes, adjust all the offsets of all subsequent objects. Write the file. You can't just change the offset. You literally have to save all the new data again, right? Write object with metadata. Then update subsequent. Yeah, and then you have to go through entire items, and if the key is found, yeah, but there's more. There should be more to this file. Where's the code that actually runs it? Write object with metadata. So does it call update? Okay, so it does. Right. So then we would open r.b. Yeah, I just feel like that's just way too much work. Like just looking at it, like that's a simple. No, I'm pretty sure there's no way. Just like no, even if it's 5 times faster, is as long as we have like, as long as we have to frequently overwrite subsequent data, which I'm like certain that means we have to re-serialize the data, right? Because once it gets over, well, no, that would mean we would just move it in the file. So we wouldn't have to re-serialize the subsequent objects using the second method, but could instead just move them before serializing the initial overwriting object that is now larger than its old version was. Yeah, I just don't think, like, there's no way that's faster. With the second method, using a metadata index, you wouldn't necessarily need to reserialize the subsequent objects. Instead, you can simply move, then update their offsets, determine space requirements, shift subsequent, open the final, start from the last object and work backward. Move each subsequent object to its new offset by copying its bytes further down the file. Write the new object. Gotcha. Okay, I understand. Gotcha. Advantages of this approach: no need to resize. Okay, get it. Gotcha. Limitations: for large files with many subsequent objects, moving all the bytes can become slow. Yeah, it seems like that would probably be slower than just switching to JSON and using it instead, right? Yes, using JSON instead of managing offsets in pickle-based file is likely to be faster, simpler, and more robust for many use cases. JSON has several advantages over the pickle offset when it comes to random access and dynamic object updates. Subscribing is text meter, debug and inspect manually. No need for complex metadata structure. JSON allows you to store objects in dictionary style format. Efficient updates, you don't need to manage offsets. You can substitute the object, load the JSON data modified in memory, and save it back. Cross-language compatibility. JSON is a widely supported format, so it works seamlessly across programming languages, and libraries are highly optimized for simple to use for encoding, decoding objects. Why you might stick with Pickle offset system, binary data. If you're working with complex Python objects, Pickle is more suitable because it can deserialize them correctly. Okay, right, so we may not actually be able to use JSON. I would like to think JSON doesn't support complex objects without custom. Well, no, it does. Yeah, we went over this. We actually don't need complicated types. We just need the simple types, right? Like we only need simple types. Like when I say simple types, we're not going to be working with Pygame objects. We're just going to be working with class instances, if that even. It might not. Well, probably would need that, but may not even need that. Anyway, we could probably just save their attributes instead of saving the actual entire objects. one by one, you know, and if that's even necessary, which may not be necessary, then we need some train of thought there. Yeah, so like integers, booleans, lists, dictionaries, strings. Of relatively small size, not like, you know, most of these pieces of data are relatively small. Some of them can be like moderately large. Some of them, um, like transferred data. Some of the dictionaries associated with card movement and stuff can be kind of long, but you know, that's like still a simple type of object that JSON would surely be able to handle. So let's see. So I think we're gonna wrap this up here, but overall, I think we're most likely just gonna switch over to JSON. Unfortunately, we were gonna try to do this offset system, and it kind of sucks that I spent time learning about that. I don't really like learning about stuff that I'm not gonna use. Like, who wants to learn trigonometry? If you're not gonna use trigonometry, it's kind of dumb, right? So, I mean, it's nice to know. And honestly, most of the stuff I learned was necessarily about files and not so much about like offset. Like, I didn't really spend so much time on that, so I wouldn't say a lot of it was wasted time. Um, PKL is a lot faster, but just ultimately, maybe we could use the offset with the buffer. Let me just, so we're going to stop here, but I will consider tomorrow, maybe we can use PKL with a buffer. So we're going to say, well, we don't really need to say anything more than that. That's what we continue to do. We didn't really make much progress. Unfortunately, we actually kind of like discovered that we need to go back and fix some things. So it stopped here. But I think overall, it's good that I realized the flaw in the system before I got any further, and that we were still at the really early stage. Okay, and I'll just put a note here, and I'll put need to figure out a if I am going to use JSON or a buffered with empty space PKL solution for save for the save file. Yeah. So we'll just put stopped at 335 in client refactor. So 335. Just go over here, and we can undo this. So I can copy that. Go back down here and paste that in, and it's basically the same line. It's 335 instead, and now we're gonna say the time that we stopped was 7:18, and we really didn't make much changes, so I'm not gonna stage commit push our changes. We're just gonna leave it as it is. We don't really need to. So anyway, we'll just go ahead and stop immediately here. So we went to 7:19, which was 1.5 hours, almost exactly, a little bit over. We didn't even take a break, so that's cool. We got some work done, which is better than nothing. Anyway, so see you next time, guys. Have a good night. Peace.